Think of these in terms of, you have a number line, right? Here's 0. And you have this continuum from negative infinity to infinity, right? And anything with y equals x, in terms of, you have a number line, right? Here's 0. And you have this continuum from negative infinity to infinity, right? And anything with y equals x is negative infinity to infinity. Y equals x squared, negative infinity to infinity, right? Because that's going to go up and to the right and up and to the left. Y equals x cubed, because that's going to be up and to the right and down to the left. So that's going to continue on negative infinity to infinity. And then you have x to the 4th, and so on, right? Because that'll kind of squiggle around, maybe something like that. Y to x to the 5th. So any of those, it's going to kind of come around and kind of come down like that. So those are all going to be negative infinity to infinity. Okay? Now what is not negative infinity to infinity? When you have y equals to the square root of x, now here you cannot have a negative radicand, right? So here you have to set the radicand to greater than or equal to 0. Because 0, square root of 0 is just 0, right? So now it's going to be closed at whatever you get x is greater than or equal to, and then goes to the right, to infinity, right? So that'll be closed at 0 to infinity. So whatever you solve for inside that radicand, that's going to be what your domain is from that point. And so inside a radical, it's always closed except when the radical is in the denominator, okay? Because we cannot have 0 in the denominator. But any other time, the radical expression is going to be negative infinity to infinity.
Well, on the online homework,
Yeah.
it says f of x equals square root of x minus square root of x plus 1. And it said
F of x equals to the square root of x minus
plus x square root of x minus 1.
square root of x minus 1. Okay, now here you have two square roots, right? So here you have to treat them separately. You have to look at this first one here. What's that domain? Okay? So you said x is greater than or equal to 0, right? Okay, so here's 0, and we know it's going to infinity, right? Now this one, x minus 1 is greater than or equal to 0. Solve for that, and we get x is greater than or equal to 1. Okay? So that one, if we draw it underneath here, here's 0, here's 1. Now this one, you cannot have anything less than 1. Why? Well, what if you have 0 in here for x? Then what you end up with? Negative 1, right? You get a negative radicand. So in that case, your domain cannot be anything less than what? 1, right? So therefore, that means your domain has to be from 1 to infinity. Even though this one says 0 to infinity, but you can't use 0, right? Because 0 will give you a negative radicand for the second one. So you have to look at both, and then look at the restrictions for both and apply them. Okay? So that's going to be your domain.
I think I got it.
So even
Okay.
if that x is greater than or equal to negative 2, you would still, because it's less than 1, you
Okay.
still use.
Okay, that's a good question. Let's say here we have again, okay, we have square root x minus, and then here we have 2 minus x, let's say, okay? Well, here's, we already know this one is from 0 to infinity, right? But here we have 2 minus x is greater than or equal to 0, right? So if we solve for that one, apply -2 to both sides, and we get negative x is greater than or equal to -2, and then we divide by -1, right? Or multiply -1. Well, what happens to that inequality sign?
X is less than or equal to.
Less than or equal to 2, right? So now, here's 2, okay? And it's less than that. So therefore, we cannot have anything less than 0, right? Because that'll give us a negative. -1 would give us a negative, right? Less than that. So therefore, we cannot have anything less than 0, right? Because that'll give us a negative. -1 would give us a negative, right? In the first one. We cannot have anything greater than 2, because if we did, like if we put a 3 in here, right? That would be 2 minus 3, that'd give us a negative. So we have to consider what's in between, right? What's going to be good for both. So that would be what? Closed and closed, right? In between, everything in between, right? So that domain is going to be bracket, 0 to 2, bracket, right? Okay? Alright, anything else?
And what about like this? Like I saw this one on the homework too. Like x plus 1, square root of x plus 1.
Square root of x plus 1,
Yeah.
same thing.
No, but it's like, and then it says minus 1 over x.
Okay, you had the square, okay, now that one is kind of the same thing with what we had here, okay? Where you have square root of x plus 1, right, over, or no, it was minus, you said?
Minus 1 over x.
Minus 1 over x, okay? Now here, you're going to set x plus 1 greater than or equal to 0, right? And you get x is greater than or equal to -1, right? So here's -1, okay? Is that open or closed? Closed, right? And that's going to go -1, which way, right or left? To the right, to infinity, right? Now this 1 over x,
Does that mean like x equals 0?
yeah, you set x equal to 0, but you can't have a 0 in the denominator, right? So you have to, in that case, x cannot be 0, right? So now, here's the other number line at 0, and is that going to be open or closed at 0?
Open.
It's going to be open at 0, and we can go to -infinity one way, positive infinity the other way, right? So, for the first one, at 1, we know we cannot do what? We cannot do what for the first one?
Do less than.
We cannot go less than -1, right? So I'll make that -1. Cannot go less than -1, right?
Yeah.
So that's going to the right. But at 0, we know that we cannot do what at 0?
Have a 0.
We cannot have the 0, right? So that at 0 it's going to be open or closed?
Open.
Open. So therefore we can have a solution from -1 to 0, but it's open at 0, and then what?
And it goes all the way
Goes
to
to
Then
infinity.
it goes to infinity from there.
So is it -1, 0, and then 0 to infinity?
-1, okay, but is that open, a bracket or parentheses?
Bracket.
Bracket to what?
0.
0, closed like that?
No, the other way.
It's open, right? Okay, good. infinity?
Open.
Open, good. Make that a better looking open, it almost looks like a bracket. Okay, so that's our domain. All right?
I think I'm starting to do this.
Yeah. So you're gonna need to do these algebraically, okay?